Hi, myself B. N. Srinivas. I'm working as Associate Professor in Marri Laxman Institute of Technology Management from ECE department. And today I'm going to explain the subject is Digital System Design. And today I'm going to explain the topic is Number System Conversion and how the number will be converted. In this case, I'm going to explain now. And the first thing is number systems mainly classified as binary, octal, decimal, hexadecimal. These are the most important things in the numbering systems. In numbering system, binary means that it have only two numbers, 0 and 1. Bi means 2. Bi means 0 and 1. So for the reason we are calling as a 0 and 1 is a binary system. So in this case, the binary system having only zeros and 1 numbers. And the next version is the octal numbers. In the previous case, binary means 2. But in octal means 8 numbers. The 8 numbers are varying from 0 to 7. Totally it's having, they starts with 0, so ending with 7. So 0 to 7 is the octal number. And next one is the decimal number. The same thing previously, octal number and previously binary number. And next thing is a decimal number. In this decimal number, it's having 10 numbers. 10 numbers means 0 to 9. And remember thing is very important thing is that in digital system number, all numbers are starts with 0 only. So for the reason in decimal number, the varying parameter is up to 10, but the ending parameter is close at 9. Why? Because every number starts with 0. So 0 to 9 is a decimal number. And next number conversion is a hexadecimal number. In hexadecimal number, I am taking the numbers from 0 to 9. Means that it's same like as a decimal number. And next thing is the and adding thing is a hexadecimal number. The alphabets will be added. Means that A to F. In hexadecimal, totally it's having 16 numbers. 16 means that 0 to 9, that is called as a decimal, and A to F is a hexadecimal. Totally 0 to F is a hexadecimal numbers. And there's a basic things in the numbering system. And after that, how the numbers will be converted are converted in the different format. For example, conversion of numbers is a decimal to other. Decimal to other means a decimal to binary, otherwise decimal to octal, otherwise decimal to hexadecimal. And next one is the other to decimal. Other to decimal means in the first case, decimal to other means I am taking the input as decimal. And other conversion has three types: hexadecimal and binary and octal. But other to decimal means that I am taking input as hexadecimal, binary, otherwise octal. But final output is a decimal. So like that, my numbering systems are converted in the remaining three formats. After that, and next thing is the numbering systems again classified as complements of numbers. Complements is classified as 1's complement, 2's complement, 9's complement, and 10's complement. And before going to the complements of a number, I'm going to explain addition and subtraction. Addition and subtraction is implemented only for binary numbers, zeros and ones. But if I am taking 0 plus 1 is 1. 1 minus 1, it comes under subtraction. 0 plus 1 and 1 minus 1. Plus indicates the addition of the binary numbers, and subtraction minus symbol indicates the subtraction of the numbers. And in future topics, I'm going to explain the weighted codes and non-weighted codes. I will explain later. And the full form, and in this case, BCD and ASCII, and XS3, these codes performs an important role. BCD means binary coded decimal, and XS3 means that one number is converted to the XS3 format. How numbers will be represented. Now I'm going to explain how the numbers will be represented here. In this case, just now I told that decimal numbers, the varying parameter is from 0 to 9. So the starting the value is 0, ending value is 9. So these numbering systems we are calling as a decimal number system. But in binary system, it's having only two numbers, zeros and ones, 0 and 1. But in octal system, the varying parameters are 0 to 7. It's having total 8 numbers, 0 to 7. But in hexadecimal number, just now we discussed, it's having 0 to 9, just like a decimal number. And hexadecimal, I'm adding A to F. Totally in hexadecimal, 0 to F is a hexadecimal. Totally it's having 16 numbers. How the numbers is represented in the decimal format. And the first thing is in decimal system is composed of 10 numerals. Means the In decimal, it's having 10 numbers, 0 to 9. So for the reason, it's having totally 10 numerals. And the values are varying from 0 to 9. And how we are representing the decimal number. And now I'm going to explain with an example. For example, if I am taking the decimal number is a 3501.51. How we are differentiating the each number. In this case, rightmost bit means this one. I'm calling a least significant digit. In shortcut form, we are calling as a LSD. Right side most bit. I'm calling as least significant digit. And leftmost means this one. I'm calling as the most significant digit, MSD. And what we are discussing the topic is decimal system. How the numbers in the decimal system will be explaining. And next, each number, in this case 3501.51. Each number I'm calling as a digit. Why I'm calling digit? Why? Because I'm going to explain the decimal system. And fractional value. Here the number is 3501.51. So that point, fraction value, I'm calling as a decimal point. So like this, now my decimal system numbers are classified as least significant digit, means right side most bit, and left side most bit I'm calling as a most significant digit. And each number I'm calling as a digit, and dot value means fraction value I'm calling as a decimal point. And how just now we explained decimal system. And like this, how the binary system will be explained. In this case, the numbers you can take in decimal system, the numbers varying from 0 to 9. You can take any number, 0 to 9. But in binary number, the value is only zeros and ones. We have to take only the possibility 0, 1. And in this case, the numbers only 0, 1 we have to take. And for example, if I'm taking the example as 1101.01. And in the same like as the previous example, right side most bit I'm calling as a least significant bit. And here I'm calling as example. Here abbreviation is LSB. But in decimal system, it is called as a least significant digit. Each number I'm calling as digit here. But in binary system, each number I'm calling as a bit. So for the reason, LSB means least significant bit. But in left hand side, this number I'm calling as the most significant bit. In shortcut form, you're calling as a MSB, most significant bit. And each number is a bit. In the previous case, the fraction value I'm calling as a decimal point. But in this case, the fraction value I'm calling as a binary point. Now, like this, my decimal system numbers and binary system numbers will be explained. How the numbers converted into different formats. For example, I'm taking decimal number. The possible ways are decimal number is converted to the octal number, decimal number is converted to the hexadecimal number, decimal is converted to the binary. And vice versa, means reverse conversion also possible. Means decimal to octal, octal to decimal format. In the same way, decimal to hexadecimal, hexadecimal to decimal format, decimal to binary, and binary to decimal. Like this, totally 12 number conversions will be explained. The number systems will be converted into totally 12 types of systems. The first thing is, I'm taking the example conversion as a binary to decimal conversion. Binary means that I'm taking the example only zeros, ones. So for the reason, I'm taking the example as binary number 1101. In this case, 1101, I'm taking only 4 bits not fixed. You can take any number of bits. For example, 5 bits, 6 bits, 7 bits. For my convenience, I'm taking the 4-bit example, a 4-bit binary number. I'm taking as the 1101. Base 2 indicates the binary number. If I'm taking the base 8, so that indicates the octal number. Base 16, that indicates hexadecimal number. So the first thing is, I'm taking the input number is a binary number, but I want the output in the decimal format. Decimal format means the 0 to 9 number I want. The first case, just now we discussed this number 1101. This one I'm calling as a LSB, least significant bit, and this one I'm calling as a MSB, most significant bit. 1101 is the binary system. So for the reason, I'm taking the fraction values. Multiplication is a 2 powers. If I'm taking the octal, we have to take the 8 powers. So first you have to start with least significant bit value 1, 1 into 2 power 0, and next value 0 into 2 power 1, 1 into 2 power 2, 1 into 2 power 3. So why you are getting only 3 numbers? In this case, I'm taking only 4-bit binary number. It starts with 0. So for the 2 power 0, 2 power 1, 2 power 2, 2 power 3. If I'm taking the maximum number of bits, the value will be increased. So 2 power 0 value is 1, 1 into 1 is 1, 2 power 1, 0 into anything is 0, and next 2 power 2 value is 4, 4 into 1, 4, 2 power 3 value is 8, 8 into 1 is 8. Finally, I'm taking addition of all values. So 8 plus 4 plus 0 plus 1. Totally 13 number is came. And finally, my input taken number is a 1101 binary number. My main motto is I want to convert binary number to decimal conversion. So in this case, my input number is 1101 is a binary number, but I want the output in decimal format. So decimal format, finally my output is 13. 13 is the decimal number. So like that, my binary number 1101 is converted into the decimal number. Next example I'm going as octal to decimal conversion. And previous one example is the binary to decimal conversion. And here example is octal to decimal conversion. And here octal number I'm taking. Octal means the number is varying from 0 to 7. But in binary number, the value is only zeros and ones. But in octal number, the value is varying. You can take any number that is in between 0 to 7. For that reason, I'm taking the value is 7. Minimum is 0, maximum is 7. So then it is called as a octal number. So in this case, my example is 5217. In the previous example, I'm taking the base value is 2. Base 2 indicates that is a binary system. But in this case, I'm taking base 8. Base 8 indicates a octal system. Octal indicates the 0 to 7. Same thing here, 5217. So this one is the octal number, and this one is the LSD, least significant digit, and here value is 7 into 8 power 0. So why I'm taking 8? So my number is, input number is octal number. So 8 power 0. Next 1 into 8 power 1, 2 into 8 power 2, 5 into 8 power 3. After doing some mathematical calculations, and finally I got the addition of the values 2703. My input conversion is 5217 in octal number, but what I got the value 2703 is in decimal. My input is in octal format, my output is in decimal format. And next conversion I'm going here is a hexadecimal conversion. In hexadecimal conversion, just now we told that the number is varying from 0 to 9 and A to F. So then only it is called as a hexadecimal. For all conversions, my input is taken something into decimal format. And here I'm taking an example as hexadecimal 1ACF. But in the previous basics, we don't know the value of ACF. So for the reason I give the values here. And first the value is 0 to 9 as it is. For A value, I am giving 10. B value, I am giving 11. Like this, A 10, B 11, C 12, D 13, E 14, F 15. So finally, in hexadecimal number, the varying parameter is 0 to 15, otherwise 0 to F. F indicates a 15. So I given some values here. So based on that one, F indicates 15. 15 into 16 power 0. So why I'm taking 16? Why? Because my input is in hexadecimal. 16 power 0. C means that the value is 12. 12 into 16 power 1. A indicates the value is 10. 10 into 16 power 2. And finally, 1 means we don't want to convert. Why? Because I'm taking the values from 0 to 9 as it is. Of that A to F. A to F only I'm taking the extra values. So 1 into 16 power 3. By doing the mathematical calculations, finally I got the values 23247. My input is in 1ACF in hexadecimal, but output is in 23247 in decimal. Like that, my input is converted in the another format. The last one is binary to decimal conversion. Binary indicates that's having the only values 101. In the previous examples, we already done binary to decimal conversion. But in this case, sir, why we have got the value of minus? Here the value is 0.101. But in the previous example, in the first example, same thing, binary to decimal conversion. But we are taking the values in the positive manner, 2 power 0, 2 power 1, 2 power 2. But in this case, my numbers I'm taking the negative, indicate I'm getting some fraction value, binary fraction. So for the reason, I'm taking these numbers in 2 power. So in the previous examples, I'm starting with this number. I'm calling this one as LSB, least significant bit. But here you have to start with this fraction number. You have to after dot, after fraction, you have to start from here. So this number into 2 power minus 1, and this one into 2 power minus 2, and this number into 2 power minus 3. But in this cases, previous example, octal and all number start with 2 power 0, 2 power 1, 2 power 2, 2 power 3. What is the previous value? For example, is one is 2 power 3, 2 power 2, 2 power 1, 2 power 0. And the previous value is 2 power minus 1. So that 2 power minus 1 starts here. After fraction value, the first value is 2 power minus 1. Next value is 2 power minus 2. And next value is 2 power minus 3. So like this, my binary input value is converted to the decimal, but all are in the fractional values. Fraction means that is the denominator values. Here 1 into 2 power minus 1, so 0.5 value I get it. And here value is 0 into anything, 0. 1 into 2 power minus 3 means 1 by 8, value 0.125. After mathematical calculations, I got the value of 0.625. And finally, my input value is 0.101, means is in binary format, fraction value. But finally, how much I calculated? 0.625. 0.625 is in decimal format. And same like as this example, octal to decimal conversion. Here also I'm taking the same fraction value, 0.25. And here also 8 power minus 1, 8 power. But the very, very important thing is if I'm taking the values 101.10. In the previous cases, I start the values 2 power 0, and here value is 2 power 1, here value is 2 power 2. But in this case, you have to start with 2 power minus 1, here I have to 2 power minus 2. So 2 into 8 power minus 1. So why I have taken 8 power minus 1 means I'm taking input as octal number, and 5 into 8 power minus 2. So like this, my octal number is converted into the decimal number, but remember the thing is for fractional values. Normal values and fraction values is different format we are using here. But in the same thing, mathematical calculations, my input value for octal is 0.25, but my output value is 0.267825 is the decimal value. And same like as the previous example, hexadecimal to decimal. Hexadecimal means 0 to 9 and A to F. So F5 means 0.F5. First I'm taking F here. F means just a previously given 15 into 16 power minus 1. 16 is hexadecimal, 16 power minus 1. 5 into 16 power minus 2. After mathematical calculations, my input is 0.F5 for hexadecimal number, and the output is 0.95703 some number into decimal format. And next, decimal to binary. Until now, any number, my input is in different, but output is in decimal format. Means hexadecimal to decimal, binary to decimal, octal to decimal. But now I'm going to reverse format. Reverse format means that previously any format into output as decimal, but here I'm taking the input is in decimal format, outputs are in different format. Means decimal to binary, decimal to octal, decimal to hexadecimal. And in this case, I'm taking the example of decimal number is 250. 250 is a decimal number. So how you are saying 250 is a decimal number? Decimal number indicates the 0 to, the number is varying from 0 to 9. 2 is within the range, 5 is within the range, 0 is within. So finally it is the decimal number. How we have to convert to the binary format. And till now, the number conversion purpose, I'm using the multiplication factors here. 2 powers and 2 power minus 1s, and 8 powers and 8 power minus, and 16 power and 16 power minus. But in decimal to binary, I'm going for fraction, dividing factor. and 250. My output is in the binary format. So for the reason decimal to binary format, my input 250 is divided with 2. So 250 is divided with 2, 125, remainder is 0 here, 125, 62, remainder 1, 31, remainder 0, 15, remainder 1, 7, remainder 1, 3, remainder 1, 1, finally remainder 1. So finally, after conversion of this number, I want to take the output from bottom to top. So fine, what I'm saying here, my decimal number is 250, but my output are converted into the binary format. The numbers are okay, but remembering, very important, in decimal to binary conversion, my output is taken from bottom to top, not from top to bottom. Okay, so 1 1 1 2 3 4 4 times we have to write here, next 0 1 0. So like that we have to take the value of binary numbers. Next, decimal to octal conversion. Same like as previous, same 250 number I'm taking. What we converted here, 250. Here are same thing, 250 here. But in the previous number, decimal to binary conversion. So for this, that will be divided with 2. But here, decimal to octal conversion. So the number is divisible by 8. So 31 times, remainder 2, 3 times, remainder 7. So the number is 372. So 250 is my decimal number, but my octal number is 372. And next conversion is decimal to hexadecimal conversion. I'm using the same number for 3 conversion techniques here, decimal to other, and 250 is divisible by 16. So finally I got the value of 15 divided with 10. 15, 10. But I'm going to write the answer in hexadecimal number. So for the reason 15, 10. F A. So finally FA 16 is my hexadecimal number. Next conversion is a decimal to binary conversion. Same like as previously, decimal to binary, but fractional number. And in this case 0.4375. If I'm taking the example as 0.4375, how to convert the binary number? So it is divisible, multiply with 2, 0.4375 to 0. Some number I'm getting. And next, what is the value you're getting? 0.8750 into again 2, 1.75. The same 0.75 I'm taking here into 2, 1.5, again 0.5 into 2. So finally I got 0. At this position I'm stopping. So finally my output value is 0.111. 0.111 is my value. And same like a decimal to binary conversion also we have done previously, but this technique is I'm using for fractional number. Decimal to octal conversion, here also I'm using same fractional number here, 0.4375. For octal conversion I'm taking 8 here, 8 into 3.5, and here 3 I'm keeping as it is, 5 is came here, 0.5 into 8, 4. So if I'm getting the position as 0, at this position we have to stop, and 0.34 is my octal number. Next conversion is a decimal to hexadecimal. 0.4375 is hexadecimal. Date I'm taking 7.0. So 7 is my hexadecimal number. And next thing is a decimal to hexadecimal to binary conversion. Out of all technique, this technique is somewhat easier. And here I'm taking the hexadecimal number as 10AF. And in this case, hexadecimal number, I'm converting each number into 4 parts here. 10AF. 1 means I'm writing for each number into 4 here. 0001, and next 4 zeros. A indicates the value is 10. The binary value is 1010. F indicates the value is 15. All values 4 ones. After mixing up all these values, 10AF 16 decimal number I'm giving here. But finally, I got the binary value as, by combining all these values, 4000 as it is 1, and you have to mix all these values. This is a bigger number, indicates my hexadecimal number 10AF is converted into the binary format. Same thing octal to binary conversion. In the previous example, my each number is converted in hexadecimal number method, each number into 4 parts. But in octal conversion, my each number 705. In this case, my each number is converted 3 parts only. 3. Why I am taking the 3 means octal is represented in 2 power 3. But in hexadecimal 16 is represented in 2 power 4. So in hexadecimal, my number is converted the 4 parts, but in octal number, my number is converted 3 parts. So 7 is written as a 3 ones, 0, 000, 5, 1, 0. After mixing of all these numbers, 111, 000, 101. This number I'm calling as a octal to binary conversion. Next, octal to hexadecimal conversion. In the same octal number, the number is varying from 0 to 7. So for the reason I'm taking the value as 1, 3, 2. First 1. In octal number, just now I told, octal number is divided into 3 parts. So 1, 0001, 3, 0110, 2, 010. So my conversion is completed. But I want to convert this octal number into hexadecimal format. Hexadecimal means we have to mix all numbers into 4 formats. So 001. So after mixing of these numbers, but representing the numbers is very important. But you have to start at this position. So 1010, one combination. After that, you have to take remaining 4 combination. 0101. 1010, the number is A, and next 101, the value is 5. So finally, I am giving the octal number as 8. My octal number is 132, but in hexadecimal, I got the value as 5A. So like this, my octal number is converted in the hexadecimal format. Okay, thank you so much. Thank you all.